Imagine walking onto like a massive automotive factory floor in the year 2028.
Okay, I'm picturing it.
You look around and something is fundamentally missing. I mean, there are no conveyor belts locking the assembly line into this single rigid path.
Right, the classic setup is just gone.
Exactly. There are no giant, blind metal arms bolted to the concrete, endlessly repeating the exact same geometric motion. Instead, the floor is, well, it's fluid.
Yeah.
You see thousands of humanoid robots walking the aisles, passing heavy car parts to each other, pausing to let a forklift go by, and adjusting their grip on a chassis in real time.
It's a wild image.
It really is. Welcome to the Deep Dive. We are looking at a paradigm shift today that is going to change how every physical object around you is made.
Truly every object. Right.
And helping you navigate massive world-altering shifts like this is exactly why today's exploration is brought to you by AI Opportune.
A great resource.
Absolutely. Because the artificial intelligence landscape is evolving so fast, it can literally make your head spin. And AI Opportune is the premier platform for staying ahead of the curve.
You really need that kind of anchor right now.
You do.
Yeah.
Whether you're trying to understand how autonomous systems will disrupt your specific industry, or maybe your investment portfolio, or just your daily life, they cut completely through the noise. So do yourself a favor, hit that subscribe button, and join AI Opportune to keep your edge.
It's the kind of dedicated radar you need right now, especially when we are moving from theoretical tech to massive industrial deployment.
And that deployment is our mission for today. We are breaking down the reality of Hyundai's 2028 operational roadmap.
A very ambitious roadmap.
Very. We're charting this transition from that old, rigid factory automation you're used to into a completely new operational standard called physical AI.
Which is a massive leap.
It is. And most importantly, we are going to explore what actually happens to human labor when a machine can finally walk, reason, and work alongside us.
It's a profound transition, really. We're essentially leaving an era where we had to, bring the work to the robot and entering an era where the robot actively walks over to the work.
Which is exactly why I'm so eager to get into this. I mean, we are officially past the viral video stage of robotics.
Oh, absolutely.
We all remember watching those Boston Dynamics prototypes a few years ago.
The ones doing parkour.
Yes,
Yeah.
doing parkour over wooden boxes or like backflipping on YouTube.
Yeah.
It was mesmerizing, but it always felt like a highly controlled science experiment.
Right, like a tech demo.
Exactly. But now, the novelty is over. Hyundai officially confirmed at CES that a fleet of Boston Dynamics Atlas humanoids is permanently heading to their $7.6 billion Georgia Metaplant by 2028.
Yeah.
They are putting these machines on the actual payroll to build cars.
What's fascinating here is that this is not a pilot program designed to generate headlines.
No, not at all.
It's a calculated strategic overhaul of industrial logistics. I mean, the capital deployment alone tells us that Hyundai views humanoid robotics as the foundational architecture for how they'll build vehicles.
And inevitably, how the world will manufacture goods from the ground up, right?
Precisely.
So to really grasp the gravity of this, we need to look at the leap in the hardware itself. Because the 2028 Atlas deployment model makes those older hydraulic prototypes look like antique clockwork.
It really does. I mean, the old models were heavy, they were loud, they leaked fluid.
Oh yeah, they sounded like a diesel engine.
Exactly. Every step sounded like a piece of construction equipment hitting the pavement. They were marvels of their time, but completely unsuited for an assembly line right alongside humans.
So the new specs are entirely different. The standout metric here is that the new Atlas operates with 56 degrees of freedom.
Which is a huge number.
Right, let's ground that in reality for a second. Think of a traditional robotic arm like trying to play a piano with a heavy medical cast on your wrist and forearm.
That's a good way to picture it.
You can hit the keys by moving your whole arm, but you cannot weave your fingers or toot your hand. 56 degrees of freedom is like taking the cast off entirely.
Yes.
It allows the robot to, snake its arm around a structural pillar, invert its wrist backward, and thread a bolt into a blind corner without ever having to reposition its feet.
The mechanical advantage there is staggering. If a human drops a component behind a crate, the geometry of our skeleton basically forces us to walk all the way around, crouch down, reach, and it...
Because we only bend in certain ways.
Right. A machine with 56 degrees of freedom doesn't have those biological constraints. It might just rotate its torso 180 degrees, invert its shoulder joint, and pluck the component right off the floor.
And just for context, the Figure 03 robot, which is a massive competitor in this space right now.
Oh, definitely.
That one only operates with 35 degrees of freedom. So Atlas is bringing a level of hyperdexterity to the floor that the competition simply hasn't matched yet.
And you couple that dexterity with a 110-pound or 50-kilogram lift capacity, and you have a machine built for brutal, heavy-duty bin handling.
Wait, let me stop you right there, because that is a massive hurdle in my mind.
Okay.
A 110-pound lift capacity is incredibly powerful, obviously. But human factory workers rely heavily on tactile feedback.
They do, yeah.
Like, a seasoned worker knows exactly how tight a bolt feels when it's perfectly torqued, or, how much pressure to apply to a delicate wiring harness.
Right.
How can a massive metal hand with that much crushing power replicate human touch without just snapping the parts in half?
Well, that is where the force torque sensors come into play. These newer end effectors, the robot's hands, basically are lined with highly sensitive haptic arrays.
Okay.
They measure resistance by the millimeter. So when the machine grips a delicate component, it is calculating the exact structural integrity of that object in real time.
Oh, wow.
Yeah, it applies only the micronewtons of force necessary to maintain friction. It has the physical capacity to crush a cinder block, sure, but the sensory fidelity to hold an egg without cracking the shell.
Okay, let's unpack this. Because that level of sensory processing requires serious computing power. I mean, the hardware is impressive, but a strong, flexible body is completely blind without a central nervous system.
It's just a puppet without it.
Right. So the real breakthrough driving this 2028 deployment is the integration of Google DeepMind's Gemini robotics AI running on NVIDIA computing architecture.
The universal brain.
Yeah.
This is the dividing line between traditional automation and true physical AI. Historically, engineers wrote deterministic code.
Meaning step-by-step instructions.
Exactly. They told the machine, rotate motor A by 12 degrees, then lower motor B by 4 inches. If the car chassis was half an inch out of alignment on the conveyor belt,
The robot would blindly weld empty air.
exactly, and the whole production line would halt.
So it was fast, but incredibly fragile.
Very fragile. Physical AI throws that deterministic coding completely out the window. The Atlas, powered by Gemini, is parsing visual data through its cameras in real time.
So it's actually looking at the parts.
Yeah, right. Recognizing a bumper or a steering column, and the neural network directly outputs the torque requirements to its joints to grab it.
Wow.
If a box is bumped 2 inches to the left, the AI sees the discrepancy, reasons about the new spatial geometry, and dynamically recalculates its arm trajectory on the fly.
It's actively perceiving and reacting, much like a human worker does.
Yes, exactly.
So it's constantly reasoning,
Yeah.
making dynamic decisions every second of every shift. Which makes me wonder how much of this is actually a traditional robot and how much is just a highly advanced AI algorithm that happens to be wearing a very strong metal suit.
The industry is absolutely leaning toward the latter. The physical shell is secondary to the intelligence model at this point.
Really?
Oh, yeah. Consider the Sim2 real transfer process simulation to reality.
Okay.
These NVIDIA integrations mean that the AI brain doesn't learn by practicing on the actual factory floor where a mistake costs $1 million.
Oh, you can't have it dropping real car doors.
Exactly. It practices in a hyper-realistic digital twin of the Georgia Metaplant. The AI attempts to pick up a digital car door, drops it 10,000 times in the simulation, refines its neural pathways through reinforcement learning, and figures out the perfect grip.
So by the time the physical robot arrives in Georgia on day one, its brain already possesses thousands of hours of flawless experiential data.
It essentially drops out of the shipping crate, possessing a master's degree in automotive assembly.
That is wild.
And it operates on a 3-minute autonomous battery swapping system. When power runs low, it just walks to a bay, swaps its own cell, and returns to the line.
No lunch breaks, no shift changes, no fatigue.
None.
Which brings us to a crucial piece of the puzzle. We have this hyper-intelligent, tireless workforce ready to deploy. But why the rush?
Yeah.
I mean, why build a $7.6 billion Metaplant in Georgia specifically for this in 2028?
If we connect this to the bigger picture, the catalyst is entirely demographic.
Demographic.
Yeah. The manufacturing sector is staring down a sheer cliff right now. Current projections from the National Association of Manufacturers indicate that by 2030, the U.S. will face a deficit of 2.1 million unfulfilled manufacturing jobs.
Wait, 2.1 million.
2.1 million.
That isn't a minor staffing shortage. That is an existential threat to domestic production.
It really is. The workforce is aging out, and younger generations are not backfilling those heavy manual labor roles. Furthermore, the financial and human toll of repetitive strain injuries on assembly lines severely impacts operational margins.
Because it destroys people's bodies.
Exactly. When human joints degrade from lifting the same components for a decade, you face massive healthcare costs, insurance premiums, and operational downtime. Atlas is not stepping in to just show off or steal coveted jobs.
It's acting as a necessary backstop,
Yes, for a looming labor void that human demographics just can no longer support.
which perfectly explains the timeline Hyundai has mapped out. They are not flipping a switch in 2028 and letting humanoid robots build an entire car unsupervised.
No.
They are executing a phased deployment. In 2028, Atlas starts exclusively with logistics. We are talking about parts sequencing, material sorting, heavy bin running, taking the highest risk, highest repetition physical burdens off the human workers first.
The grueling tasks that destroy knees and lower backs.
Right. But the roadmap escalates quickly from there. By 2030, these machines transition from just moving boxes to complex component assembly.
Actually putting the vehicle together.
Yeah. And the mechanism they are using to achieve global scale post-2030 is something called the software-defined factory, or SDF.
This concept is the ultimate multiplier effect in modern manufacturing.
It really is.
Yeah.
I mean, think about the smartphone in your pocket. You go to sleep, and overnight, your phone downloads a silent update.
Right.
When you wake up, the camera software has been optimized, and it takes significantly better low-light photos. The hardware didn't change at all, but the device learned a new trick.
It got smarter.
Exactly. Now, apply that concept to a global manufacturing footprint. If an AI model running in a server farm somewhere discovers a 4% more efficient way to route a complex wiring harness, it beams that update down from the cloud.
Yeah.
The next morning, every single Atlas robot in every single Hyundai plant on Earth executes that new technique flawlessly.
And you compare that to human retraining.
It's night and day.
It really is. If engineers develop a new assembly method today, you have to fly trainers to facilities around the globe, pull workers off the line in small batches, run instructional seminars.
Deal with the learning curve.
Exactly, you endure a long curve of human error as they build muscle memory. The software-defined factory achieves instant, perfect global synchronization of skill.
So what does this all mean for the humans actually standing on those factory floors today? Because I need to play devil's advocate here.
Sure.
The tension surrounding this transition is palpable. Hyundai is heavily messaging this as a human-centered robotics initiative. But labor unions are throwing up red flags, actively warning about severe employment shocks.
Which is understandable.
Absolutely. So I have to ask, is human-centered just a slick piece of corporate PR designed to mask the wholesale replacement of human hands?
It's a vital question. And looking at the data objectively, both perspectives hold weight.
Okay.
The unions are completely justified in their concern regarding traditional displacement. If an AI-driven humanoid is handling all parts sequencing by 2028 and taking over complex assembly by 2030, the demand for baseline manual human labor on that specific floor will inevitably plummet.
You can't deploy tireless machines with 56 degrees of freedom and pretend the old jobs will remain untouched.
You really can't.
The jobs that require sheer physical endurance are simply going away.
They are. However, the corporate stance of a human-centered evolution isn't entirely fiction either. The scale of this transition requires human oversight of a completely different kind.
Right.
Hyundai is injecting $26 billion into the U.S. robotics ecosystem. That includes a dedicated humanoid production facility capable of turning out 30,000 Atlas units annually by 2028.
30,000 units a year. That is, they are essentially mass-producing a mechanical standing army.
They are, and an army requires a massive logistical tail. That scale creates an entirely new stratum of high-skill human employment.
Like what kind of roles?
Well, we are looking at a massive demand for robot fleet orchestrators, sim-to-real training engineers, sensor calibration technicians, and maintenance crews who can actually service those advanced haptic arrays.
So the human role elevates from exerting physical force to managing the systems that exert the force.
Precisely. The Georgia Metaplant is basically serving as the premier live lab to figure out this human-robot collaborative ecosystem. The human worker is no longer the gears of the factory, they become the conductor of the orchestra.
Here's where it gets really interesting, though. Hyundai is betting $26 billion on this vision, but they are not operating in a vacuum here.
It's not at all.
We are watching a blistering robotics space race unfold right now.
The market dynamics here are just phenomenal. As we look at the landscape in 2026, the humanoid sector is valued at roughly $1.4 billion, but the projected trajectory is a 30.4% compound annual growth rate straight through 2033.
Which is massive. And we should clarify why that explosive growth is unlocking right now and not, say, 10 years ago.
Yeah, that's important.
It's a convergence of three separate technologies finally hitting maturity at the exact same time. We have next-generation lightweight batteries, massive decreases in the cost of computing power, and the sudden maturity of large vision models that allow the AI to actually see and interpret the chaotic real world.
The hardware finally has a brain powerful enough to drive it and a battery dense enough to sustain it.
Exactly. And that convergence has triggered three wildly different strategic philosophies among the major players fighting for market dominance.
Right.
First, you have Tesla's Optimus program. Their entire ethos is commoditization and mass market scale. They are aggressively targeting a price point of $20,000 to $30,000 per unit.
A very different approach.
Yeah, they want to drive the cost down so far that every small business, warehouse, and eventually suburban household treats a humanoid robot like a standard appliance.
It is the Model T approach to robotics. Just flood the market with accessible baseline units.
Then you have Figure AI taking a totally different path. They are heavily focused on high-profile, multi-purpose corporate pilots integrating directly into existing workflows with partners like BMW.
Proving versatility.
Right, they're trying to prove sheer versatility within legacy systems. And finally, you have the Hyundai and Boston Dynamics alliance. They are bypassing the cheap mass market race entirely.
Yeah, they aren't interested in that.
They are building unstoppable, heavy-duty industrial muscle combined with the absolute cutting edge of Google DeepMind's cognitive processing.
We are witnessing a fundamental divergence in engineering philosophy here. One pursues volume, one pursues adaptability, and one pursues absolute industrial supremacy.
It feels exactly like the early days of personal computing or the dawn of the smartphone wars. You had Apple's closed, highly curated hardware ecosystem battling Android's open-source volume approach.
That's a great comparison.
Only this time, we aren't fighting over what operating system runs the glass screen in your pocket. We are watching titans battle to establish the default operating system for moving, lifting, and manipulating the physical world around us.
The philosophy that wins this race will dictate the architecture of global commerce for the next century.
So bring all these threads together. What we're really looking at with Hyundai's 2028 roadmap is a company that is no longer just building cars. By integrating hyper-dexterous hardware with generative AI brains, they are actively manufacturing the workforce of the 2030s.
Yeah, that's exactly what they're doing.
And for you listening, whether you work in tech, whether you run logistics, or even if your career seems entirely disconnected from manufacturing, this shift will touch your life. The fundamental cost, the speed of production, and the underlying method of how every physical good you interact with is created is about to be driven by software that can reach out and touch the real world.
This raises an important question, though, one that extends far beyond the perimeter of the Georgia Metaplant.
Okay, what is it?
If physical AI scales flawlessly through these cloud updates and humanoid robots become the default hyper-efficient workforce for all heavy labor by the early 2030s.
Which seems very likely.
Right. How will human society value human physical effort?
Oh, that is a fascinating pivot.
Consider the inverse of our current reality. When every vehicle, every appliance, and every piece of furniture is assembled flawlessly down to the micrometer by a machine that never sleeps and never makes a mistake.
Will imperfection become valuable?
Exactly. Will assembled by a human become a premium luxury label? Much like we pay exorbitant markups today for handcrafted leather or artisanal furniture, will future consumers pay a massive premium simply for the knowledge that a human hand, with all its biological inconsistencies, touched the product?
Wow. A mass-market car built by AI for $20,000 sitting next to a luxury vehicle built by human hands for $200,000.
That's the reality we might be facing.
That is a wild economic inversion. I really want you to ponder that idea today because, as this roadmap proves, the timeline on this technology is collapsing faster than anyone predicted. 2028 is essentially tomorrow.
It really is.
Thank you so much for joining us on this deep dive. And remember, decoding these massive technological shifts and understanding how they will rewrite our economy is exactly why you need AI Opportune.
Make sure you subscribe.
Yes, subscribe to them so you can keep navigating these incredible changes with us. Next time you picture a factory floor, erase the bolted metal arms from your mind. Imagine the machinery unbolting itself, waking up, and walking right into the future. We'll catch you next time.